Hi, welcome to the Unit 5 Day 1 to Day 4 review instruction and answer video. So in the first part of this video, I will go over the instructions of how you're going to complete this review document, this graphic organizer. And in the second part, I will go over the answers with you so that you have them. You'll need to be able to try this on your own in order to complete the exit ticket. All right, so let's get started. As it says here in the instructions, your job is to complete this graphic organizer, which reviews the information that we covered over the last 4 days for Unit 5 using the word bank below. So essentially what you're going to do is wherever you see these red brackets, those are your blanks. You're going to fill them in using one of the words in the word bank. Now, the words in the word bank, some of the words are not used at all. So there's some words you will not use. And then there are other words that may be used more than once. So just keep that in the back of your mind. You'll also notice that there's a positive and negative sign also in the word bank. So hint, hint, you're going to use those for the delta H and delta T. What's the sign? Are they going to be positive or negative depending on the type of reaction you have? So what you're going to do is you're going to pause this video now and you're going to read through each section of the graphic organizer and then try and fill it in. Now to help you with doing that, by the way, you'll notice in blue it will tell you the day that this information was covered. So if you're not sure how to fill that in, you might want to take a moment and review the notes in that folder to help you. All right. So with that being said, pause the video and when you press play again, the answers will be revealed. Okay, so at this moment, you should have tried to fill these in on your own and or using your notes. So let's go over the information that is there, starting at the top. The first thing we learn in this unit is what happens during a chemical reaction. And during a chemical reaction, bonds in the reactant are broken and new bonds are formed in the product. Now, that information is important for understanding both kinetics and thermodynamics. Let's start with kinetics. So kinetics is the study of rates of reaction or reaction rates and basically how fast or how slow a reaction is. And the thing about kinetics, there are 5 factors that affect the rate of a reaction. So what you're supposed to do here is go through each of these 5 factors and figure out how you can increase the rate of the reaction by changing that factor. So the first one is concentration or amount. If you increase the concentration or amount of a reactant, the reaction rate will increase. The reaction will be faster. For temperature, if you increase that as well, it'll also increase the rate of the reaction. For surface area, if you increase the surface area, that increases the rate of the reaction. And when we say increasing the surface area, that means that we're breaking solids down into smaller pieces. So the smaller the pieces, the faster the reaction. The next one is agitation or stirring. If you increase the amount of stirring or agitation, it increases the rate of the reaction. And finally, adding a catalyst, which is something you can add to a reaction to increase its rate. So adding a catalyst will increase the rate of the reaction. So that is kinetics. Now let's move on to thermodynamics. So for thermodynamics, that involves the study of energy changes during a chemical reaction. And this is related to the process of breaking and forming bonds, because when you break bonds, that requires energy. So you have to put energy into the reaction in order to break the bonds. And when you form bonds, when forming the product, you're forming new bonds, that releases energy. Now, depending on the balance between the amount of energy you have to put in and the amount of energy that's released during a chemical reaction, you can have one of 2 situations. You can have an endothermic reaction. And in an endothermic reaction, you have to put more energy in to break the bonds than is released when forming the bonds. So overall, in an endothermic reaction, heat is gained. And we can symbolize that through this delta H. Delta H stands for change in enthalpy. So since heat or enthalpy is gained, that means the symbol for delta H will be positive because you're gaining it. Now, for an endothermic reaction, because it's absorbing heat or gaining heat from the surroundings is going to feel cold, and that could be your hands or the container that it's taking place in. So since the surroundings will feel cold, the change in temperature of the surroundings will decrease, so delta T is negative. Now you look at the reaction profile shown at the bottom for an endothermic reaction. The reaction profile shows the products having higher energy than the reactants, and that's because overall this reaction gains energy. So in the end, the products will have more energy. Let's move over to exothermic. So for exothermic, this has to do with in cases where more energy is released in forming bonds than is put in to break the bond. So overall, there's a release of energy or heat. And since heat is being released or lost, that means that delta H, change in enthalpy, is negative. Now, since it's being lost into the surroundings is going to get hotter. So the surroundings will feel hot, and that will result in an increase in temperature. So delta T is positive. So if you look at the reaction profile for an exothermic reaction, you will see that the product is lower in energy than the reactant. All right, last thing, going into chemical reaction equations. These are used to represent chemical reactions, and the main thing is in writing a chemical reaction equation like the ones you see at the bottom here, the reactants are going to be found on the left side of the arrow, and the products are going to be found on the right side. What you're starting with, your reactants are on the left, and then your products are on the right. Now, finally, it's important, according to the law of conservation of mass, for us to balance a chemical reaction equation. And when you're balancing it, you're trying to make sure that you have the same number of atoms of each type on both sides of the arrow. So if you look at the example here, the first equation is unbalanced because we don't have the same number of oxygens on both sides. In the second equation, it's a balanced equation because they're the same number of both types of atoms, hydrogen and oxygen on both sides of the arrow. Now, to balance the equation, it's important that you change the coefficient, which is the big number in front, and not the subscript, which is the small number in the chemical formula. So you don't change the subscript, but change that coefficient. All right, that's it for this video. So now what you're going to do is in your exit ticket, you're going to answer the questions or sort of have you think about what things do you know, what things do you think you need more practice on. All right, that's it for this video. Have a quality day.